Hello everyone. This is the worksheet on binomial probabilities, and we are going to go through the problem step by step. We're going to start with how to find factorials, and then into how to calculate binomial coefficients, and eventually get to calculating binomial probabilities. All right, so the first set of questions says find the following factorials. Now, in order to calculate factorials, all we need to do is we start from the number. All right, so we start from the number whose factorial we are calculating, so 3, and then multiply that by 1 less than 3, which is a 2, multiplied by 1 less than 2, which is a 1, and then stop at 1 and complete the multiplication. So 3 times 2 times 1 is 6. So 3 factorial has a value of 6. What about 7 factorial? Again, same process. You start with the value whose factorial you are going to find. So 7 multiplied by 6, multiplied by 5, multiplied by 4, multiplied by 3 times 2 times 1. So again, for this you will need a calculator, of course. So when you complete the multiplication, 7 times 6 times 5 times 4 and all that, then you should come up with a value of 5040. 8 factorial, again, same thing. It's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 should give you a value of 40320. For 9 factorial, now I'm going to just give you the final answer for that. You can do the calculation yourself and check whether you're getting that value. It's 362,880. And finally, we have 0 factorial. 0 factorial is 1. All right, it's a constant value. 0 factorial is 1. Okay. Now we will go into calculating some binomial coefficients using the formula that we learned, as well as using or applying factorials. All right, so the formula for calculating binomial coefficients is n, then a k or x. K can also be x, all right, and then surrounded by brackets. This kind of bracket means n combination k. That means how many combinations of size k can you come up with from a size of 9 items or 9 people or whatever you may be working with. Right, the formula for it is n factorial. So in the numerator you have n factorial, and then k factorial times n minus k, and then again factorial. All right, again, in many areas, in many places, you will see instead of k they have an x. So x is the value at the bottom. All right, so over here for question number A, it has 5 and 3, so that means n is, and let me use a different color so it stands out. All right, n is 5 and 3 is k or x, whatever it is. All right, and then let's write the formula first. N factorial divided by k factorial times n minus k factorial. So n is 5, so 5 factorial divided by k is 3, so 3 factorial times 5 minus 3, and then factorial is outside the bracket. All right, so it's not 5 minus 3 factorial, but 5 minus 3 calculated, and then the factorial. So let's do the calculation of the factorials now. So in the numerator, we have 5 times 4 times 3 times 2 times 1. And then in the denominator, first 3 factorial is 3 times 2 times 1. And then 5 minus 3 factorial is 2 factorial, correct? So let's add that here, 2 times 1. And now we have to simplify this again. You can use your calculator if you wish, but because these are small numbers, all in factored form, I'm going to just do the division over here. 2 and 2 divide 1 and 1 divide 3 and 3 divide 4 divided by 2 is 2. So we have 5 times 2. 5 times 2 is 10 divided by 1 is 10. All right. 6 combination 2. Again, always have the formula before you. It's so much easier to plug in without making mistakes. K factorial times n minus k factorial in the denominator. N is 6, so 6 factorial divided by k is 2, right? This is k, and the top one is n. So 2 factorial times 6 minus 2 factorial, which is 6 factorial divided by 2 factorial times 4 factorial, isn't it? So it's 6 times 5 times 4 times 3 times 2 times 1 divided by 2 times 1, and then 4 factorial is 4 times 3 times 2 times 1. Again, I'm going to do the division and factored form. All right, divide the factors. 6 divided by 2 is a 3. So I think we have eliminated almost everything. So 3 times 5 is 15. 15 over 1 in the denominator, which is a 15. 6 combination 0. Again, write the formula so it is easier to plug values in, and also it keeps you on the track. All right, it'll help you move to the next step. So k factorial, again k factorial times n minus k factorial. Again, n is 6, k is 0. So n factorial is 6 times 5 times 4 times 3 times 2 times 1. And then 0 factorial. Oh, we forgot to. Okay, let's redo this. Sorry about that. All right, let's plug in the values first. Let's not skip steps. That's not good. So 6 factorial, k factorial is 0 factorial, and then 6 minus 0 factorial. All right, so now let's do this. 6 times 5 times 4 times 3 times 2 times 1. 0 factorial we know is a 1, and 6 minus 0 factorial is 6 factorial, so that would be 6 times 5 times 4 times 3 times 2 times 1, which is going to be a 1. All right, all this is going to divide, correct? And we will end up with 1 for our answer. Now, let me tell you this, because you can just use this fact. Whenever you have 6 combinations 0, you are always going to end up with a 1. Doesn't matter what n is, whether it's 3 or 6 or 8 or 17 or 1000, doesn't matter. As long as the number at the bottom is a 0, you should always end up with a 1. All right, it can save you some time while doing the calculations. Now 5 combination 5, let's see how this works. So again, formula n factorial k factorial times n minus k factorial. Let's plug in the values. 5 factorial divided by 5 factorial, right? K is 5, n is 5 as well here. And then 5 minus 5 factorial. So 5 minus 5 factorial is 0 factorial. So this time 2, you will see we will end up with a 1 for an answer. 5 times 4 times 3 times 2 times 1. Again, this 5 factorial is 5 times 4 times 3 times 2 times 1, and 0 factorial is 1, but it doesn't make any difference. These divide, so we will end up with 1 over 1, which is a 1. Right? So again, this is another fact to remember, just like the previous one. If you have a 0 at the bottom, you will always end up with a 1. If n and k are the same values, you will end up with a 1 also. All right? 5 combination 1. So again, just write it down. N factorial. Again, this is n, this is k, correct? So k factorial times n minus k factorial. So n factorial would be 5 factorial, k factorial is 1 factorial, and n minus k is 5 minus 1 factorial. So let's do the calculation. 5 times 4 times 3 times 2 times 1 divided by 1 factorial is a 1, and 5 minus 1 factorial is 4 factorial. So times 4 times 3 times 2 times 1. Divide this. 5 divided by 1 is a 5. Again, this is another fact you can remember. Just know, if you have a 1 in the bottom for k, doesn't matter what value n is, you will always end up with n for the answer. So whether this is 3, whether n is 3 or 7 or I don't know, a million, as long as the bottom value, k value or x value is a 1, you will always end up with n for your answer. Okay, these are some good facts to remember. It helps when working on more complex problems. Hello everyone, we are now going to work on a complete binomial probability question where we will apply the different rules, the different formulas we had learned before, such as the factorials, the binomial coefficient formula, and so on, for this particular word problem. Now, this word problem we had actually introduced in our lecture, but let's read through it one more time. It's about mortality, and it says, according to tables provided by the National Center for Health Statistics, there's roughly an 80% chance that a person of age 20 years will be alive at age 65 years. Suppose that 3 people of age 20 years are selected at random. Find the probability that the number alive at age 65 years will be exactly 2, at most 1. These are all the different scenarios or events whose probability we will need to find. So what they are saying is there is an 80% chance. They've calculated and found that there's an 80% chance that a 20-year-old person, a person who's 20-year-old today, will be alive at 65 years, will be alive till the age of 65 years. And given that probability, given that chance, what is the probability that we will find 2 people alive, 3 people alive, and so on, based on random draws of 3 people? All right, that's what this problem is about. We will revisit the wording again as we go through it, but let's go through the different steps that we are being asked to answer. Step 1 is identify a success. So what is a success? What are we looking for? A success is the particular specified attribute that we are looking for in our study, right? So here it says that find the probability that the number alive at age 65 years will be so and so. So what we are looking for is the number alive, all right, and that's our success. If we find somebody alive till the age of 65, that's a success, all right. So the way we are going to answer is identify a success. Success is finding a person of age 20, and let me take out my pen and start writing here. Finding a person of age 20 to be alive at 65 years, or to be alive at 65 years or until 65 years. All right. Next is determine P, the success probability. Let me just go back to the previous step because I forgot to mention something. The way you can find out the success is by reading through the question again. It says here, find the probability that the number alive. So we are interested in finding the probabilities of the number alive. That's what our interest is, and that will be regarded as the success. The specified attribute here is the number of people found alive until 65 years. All right. Now, step 2 says determine P, which is the success probability. How do we determine the probability of finding somebody alive at 65? Again, we have to go back to the wording in the question. So let's again read from the beginning. According to tables provided by the National Center for Health Statistics, there is roughly an 80% chance that a person of age 20 will be alive till 65. So what in this sentence tells us about the probability? Keep in mind the probability has to be a value between 0 and 1, right? But here we don't have a value between 0 and 1. Instead, we are given an 80% chance. We are given a chance in percentage form. So you can always convert the chance in percentage form to decimal, which is divided by 100, and that's your probability value. So P is going to be 0.80. All right. So you have to calculate the probability from the percentage given in this question. All right. Now, sometimes they will give you the probability. It will say that there's a probability that of 0.8 that a person of age 20 years and so on. They could give you the exact probability value, but here they've given it to us in percentage form using the word chance with it. Chance is stated in percentage. Probability always has to be a value between 0 and 1. So we got our probability value. Now, at the same time, we can also calculate our failure probability. Success probability is 0.8. However, the failure probability is 1 minus whatever the success probability is. So 1 minus P, or 1 minus 0.80 equals 0.20. That's the failure probability. All right. 0.20. We will need to use 1 minus P in our calculations for probability. So you have to do that calculation at some point. All right. Now, step 3 says determine N, or the number of trials. Again, to answer this question, we will need to go back to our word problem and read through it again. So the first question doesn't say anything about the number of trials. That means how many draws we are going to make, right? However, let's read the second sentence here. It says, suppose that 3 people of age 20 years are selected at random. So over here, the number of trials, or N, is somewhat camouflaged. They have written that in word form. Instead of writing it as a number, they have said 3 people, 3 written out as in word. All right. So they kind of camouflaged the number of trials. So it's very important that you read your question over and over again to find all the information you need. All right. So, and they do this pretty often in the questions. There will be some parts which are camouflaged. So over here, 3 is not standing out because it's written as a word. All right. But they're going to draw 3 people at random to see whether they are alive until age 65 or not. All right. So here the number of trials, N, is going to be equal to 3. N equals 3. Step 4, write the binomial probability formula. For that, you need to look up your formula sheet. And this is the formula. The formula is N combination K. All right. So the probability formula is N combination K times P raised to the power K times 1 minus P raised to the power N minus K. All right. K is the bottom value in this binomial coefficient notation. All right. Now it says step 5, write the formula with specific values. So let's see what specific values we already found. We know N is 3. We don't know K. K will depend on the events whose probability we are trying to find. All right. So we will get values of K pretty soon once we go into finding the probabilities. So it's 3. N is for sure. All right. It's 3. It's not going to change. K is going to vary. P is 0.80. For this question, P is going to remain the same for the rest of this problem. So 0.80 raised to the power K. Again, K will be determined by the different events whose probability we are trying to find. 1 minus P is also, we already found it, 0.20. But let me just write it as 1 minus 0.80. So I plug in the values into the formula exactly, showing where I plugged in what. All right. Because if I just replace 1 minus P with 0.20, it might be confusing for some students. All right. So N is 3 and then minus whatever K is. Okay. So this is the formula we are going to use. We've partially plugged in some of the values. Now solve for exactly 2. That means what is the probability of finding exactly 2 people alive at age 65? Okay. So let's work this out. All you need to do is plug in values into this formula and do the calculations correctly. Okay. So exactly 2, that means K is 2. Remember I said in order to find the value of K, we have to look into the events whose probability we are calculating. So we are at that point now. Now for the first question, our K is a 2. So our formula is going to be 3 combination 2, 0.80 raised to the power 2. This is K, correct? Raised to the power 2 times 1 minus 0.8 raised to the power 3 minus 2, which is going to be a 1. Correct? So let me just write it down again. 3, just a second. It's not 3 divided by 2. Please don't make that mistake. 3 combination 2, 0.80 squared, and then 1 minus 0.8 is 0.2, and 3 minus 2 is 1. All right. Always, this is just a hint, a tip, which might help you. When you add up the two exponents, it must equal the value of n. So 1 plus 2, it should be a 3, then that should be equal to whatever n is, whatever the value of n is. All right. That's just one way to make sure you got the exponents right. So first we have to calculate 3 combination 2 using the binomial coefficient formula, and I'm going to work that on the side here. What was the binomial coefficient formula? It was n factorial times k factorial times n minus k factorial. That's the formula. So 3 factorial divided by k factorial is 2 factorial times 3 minus 2 factorial, which is 3 times 2 times 1 in the numerator and 2 times 1, and this is 1 factorial, which is a 1. All right, and now when we calculate this 2, 1, these all divide, so we are left with 3 over 1. So 3 combination 2 is going to be 3. All right, I did the calculation on the side. You can also do that. But show all your work, because it'll help you get partial credit even if you miss getting the final answer correct. If you've shown all your steps and worked them out correctly, then you will be graded based on the steps. All right. Now 0.80 squared, and then 0.2 raised to the power 1 should, and again I'm writing all the steps, 0.80 whole squared is 0.64, and then times 0.2 is going to be equal to 0.384. So the probability of finding exactly 2 people alive at age 65 is 0.384. Always write your values, show your probability values up to 3 decimal places unless otherwise stated. The next one says at most 1. So here we are now faced with finding our understanding. First, we have to clearly state what at most 1 means. We have to understand that, what at most 1 means. So let me just move this to the next page. Okay, so at most 1 would be 1 being the highest, but it cannot be more than 1. All right, so the probabilities we are looking for when they say at most 1 is the probability of finding somebody, finding 0 people alive, or the probability of finding 1 person alive. All right, so again, probability of 0 people alive or probability of 1 person alive would be covered by at most 1. So this time, of course, or means add. Remember, the special addition rule still applies here. So the way we are going to write this is 3 combination 0, 0.8. Let me work it below. All right, so just give me a minute here. So we have to find probability of 0, we have to find probability 1, and then add them up together. Okay, so probability of 0 would be 3 combination 0, 0.8 to the power 0, right? This is our k. So 0.8 raised to the power k. Again, let me write the equation here one more time. Nk. And then p raised to the power k, and 1 minus p raised to the power n minus k. Right? So P was 0.8 raised to the power 0, which was K, and then 0.20, 0.2 raised to the power N minus K is 3 minus 0 is 3, correct? And then to it we will add the probability of 1, finding one person alive. So that would be 3 combination 1, and then 0.8 raised to the power 1 and 0.8 raised to the power 3 minus 1. N minus K, 3 minus 1 is a 2. Again, you can always cross-check, verify, add up the exponents and see if it's equal to whatever N is, 3. So now we'll do the calculations on the side. 3 combination 0 is how much? It's 3 factorial divided by 0 factorial times 3 minus 0 factorial. So 3 times 2 times 1 divided by 1 times, again, 3 times 2 times 1, which is 1. All right. And when we were working through the problems on binomial coefficients, we said that if K is 0, then no matter what N is, the answer will always be a 1. All right, so let's write that down. 1 and then 0.8 raised to the power 0, 0.2 cube. Let's find 3 combination 1 is going to be 3 combination 1 is again 3 factorial divided by 1 factorial times 3 minus 1 factorial, which is 3 times 2 times 1 divided by 1 times 2 times 1, which is a 3, right? So 3 combination 1 is a 3, so this evaluates to a 3, and then we have 0.8 raised to the power 1 is 0.8 and 0.2 squared. 0.2 squared. So now we have, oops, sorry. Okay, so 0.8 raised to the power 0 is 1, right? And so 1 times 0.2 cube is going to be, just a second here. I'm trying to check the calculation. 0.008 plus 3 times 0.8 times 0.04. So we'll end up adding 0.008 plus 0.096 for a probability value of 0.104. 104. So you have to write out the answer as a sentence saying the probability of finding at most 2 people, or sorry, at most 1 person alive, 1 person of age 20 alive at age 65 is whatever the probability value you found, 0.104. All right. So now the next one says at least 1. Okay. Now part C of the question says what is the probability of finding at least 1 alive? So at least 1 means it could be 1 alive or it could be 2 or 3 as well. All 3 are accepted. You could have a situation where only just one person is alive, or 2 persons is alive or are alive, or 3 persons are alive. All right. So at least 1 means the probability that x is greater or equal to 3. At least 1 means 1 is the lowest value, but it could be higher than 1 as well. It couldn't go less than 1, at least. So it has to be, the lowest value has to be a 1 or greater than 1. So let me correct that. I don't know why I wrote a 3 there. So probability of x greater equal to 1 will be these 3 probabilities. So x equals 1 plus probability of x equals 2 plus the probability of x equals 3. Right? Now x equals 1 and x equals 2 we already calculated previously for when we did our work on at most 1 and exactly 2. So we are going to reuse those values, but I'm going to write out the formula for calculating x equals 1 and x equals 2. But x equals 3, we definitely have to find the value. All right, do the calculation for the value. So probability of x equals 1 would be this way: 3 combination 1, 0.8 raised to the power 1, 0.2 raised to the power 2. Plus probability of x equals 2 would be 3 combination 2, 0.8 raised to the power 2, 0.2 raised to the power 1. Plus probability of x equals 3 would be 3 combination 3, then 0.8 raised to the power 3 and 0.2 raised to the power 0. Correct? So 3 combination of the probability of x equals 1, we already know the value is 0.096 plus for exactly 2, what was the value we found here? It was, I think, 0.384, correct? 0.384, 0.384, but 3 combination 3, this one we need to find out the probability of x equals 3. Again, the formula, the binomial coefficient formula is 3 factorial divided by 3 factorial times 3 minus 3 factorial. Three minus 3 factorial. So 3 factorial is 3 times 2 times 1. This 3 factorial in the denominator would also be 3 times 2 times 1. And 3 minus 3 is 0 factorial, which is a 1, which will give us a result of 1. So again, when we were calculating binomial coefficients, we said this: when the n and k are the same values, then the answer is always going to be a 1. All right, so plus 1, 0.8 cube, and 0.2 raised to the power 0 is a 1 as well. So we'll end up with these values here: 0.096, 0.384, and then z plus 0. This calculates to 0.512. When you sum up all these probabilities, you should get a probability value of 0.992. And again, always write it in a full sentence, the final answer. The probability of finding at least one person alive, one person of age 20 alive is alive at 65 years is 0.992. Is 0.992. Okay, now the next question is the probability distribution. In other words, is it a normal distribution, or is it left skewed or right skewed? That's what they're asking you to give. All right, so in order to determine the distribution, you have to look at the value of p. So p here is 0.8, and you have to compare it with 0.5. All right, if p is greater than 0.5, Okay, then it's going to be a left skewed distribution. The rules, let me list the rule here. If P is, for P less than 0.5, it's going to be right skewed. Okay, it's going to be right skewed. For P greater than 0.5, it's going to be left skewed. And if P is equal to 0.5, it's going to be symmetric. Symmetric. So you have to remember these rules to answer this question on distribution. Next, it asks you to find the mean. The formula for the mean is extremely easy for binomial probabilities. It's n times p. N, the total number of trials, p, the success probability. So n is, what is n? 3, correct? And p, success probability, was 0.8. We've been using that number for all our probability calculations, so it's going to be 2.4. All right. How do we interpret that? What does this mean of 2.4 mean? It implies on average 2.4 persons of age 20 are expected to be alive at age 65. So on an average, you can expect 2.4 people to find 2.4 people alive at age 65. Standard deviation, the formula for the standard deviation is square root over n times p multiplied by 1 minus p. All right, so let's plug in the values. 3 times 0.8 for p and 1 minus p is 0.2, which is going to be square root over 0.48 for a value of 0.693. All right, 0.693. So this is how you're going to work on the binomial probability questions. Again, you will have to first get all your information, extract all your information from the wording, determine what a success probability is, the number of trials. Sometimes the information is camouflaged, so you have to read your question carefully to extract the data. All right, and then find different probabilities, the probability distribution, and then of course mean and the standard deviations. All right.